Okay, so here's that same spreadsheet of data from that other textbook I used to use. And I'm using this because I've already got it done. I don't have to pull it out of the other textbook. So it's that same, I don't know if you watched my spreadsheet video about how to do this, but here's the same data. Now, one problem with this applet that I'm going to show you is that it's not going to like the percentages. So somehow we're going to strip those off. You can do it by hand. Just go through and enter it like, hit it like that and hit enter and do that. That's not hard. We can also use some tech. I don't know if you've ever done a find and replace. Let's see, how do we get it? Is it edit? Is it under edit? Yeah, see, find and replace. And we want to find the percent symbols and we're going to replace them with nothing. Make sure that's empty. And I just want to replace it on this sheet and replace it all. And you see how it strips those right out of there really nicely, very quickly. And then we also just, so the other question that I have is we got to decide what's the explanatory variable, what's the response variable. I think calories can be explained by the alcohol content, right? The higher the alcohol content, probably the more calories in the beer. So I'm just going to select that. I'm going to let this be my x variable. And I'm pretty sure to use this applet, you want to use your x variable on the left, your y variable on the right, your explanatory on the left, response on the right. And you want them in columns or it won't understand it. So I'm going to copy and paste those into that applet. And see, I already tried this. Let me reset. I want to make sure I knew what I was doing. So I've pasted in that data. I'm going to update the plot. But let me uncheck some stuff because originally it wasn't checked. So in fact, let me close hide residuals. There we go. So here's the data. That's the alcohol content versus calories. And I'm seeing, what am I seeing? I'm seeing a fairly strong linear positive, I'm feeling strong, a fairly linear association if I'm adding a point in there. Let me reset. Let me paste this. Update plot. So I'm seeing a strong linear positive association. Notice I'm not using the word correlation. So I see a strong linear. I'm talking about shape, type, and strength. I think it's fairly strong. I think it's linear, and it's positive. There's 10 data points we see. So this applet lets you fit your own line. Can also display the line of best fit. That's the least squares regression equation. Probably ought to show you that other applet in case you don't see it on the other one of why it's called the least squares regression equation. Notice it's not going through every point. It's kind of what it is. It's kind of tried to find the average distance between it. One point it does go through is the average of the x's and the average of the y's. This linear regression equation will go through that average of the x's, average of the y's. All right, so there's my slope. There's my y-intercept. There's my correlation coefficient, 0.94. I knew it was pretty strong. I knew it looked fairly linear. That correlation confirms that. Yeah. Where do I want to go with this? Okay, yeah. So how good is this data? How does it is this data a line a good fit for this data? Certainly, it looks at. There's some things we can do to decide. One thing we want to do is you want to find r squared, and r squared is just the correlation coefficient squared. Here, let me stop this video for a minute, and I'll get my graphing calculator up. Okay, so what we're going to do to get the r squared, the coefficient of determination is one name for it. The other name of it is the percent of variation. So I'm going to take my 0.945 and I'm going to square it. I'm going to graph it. Whoops, it has to be nice if I typed in the right number. 0.945. And I'm going to square it. So there's a square button on one of these calculators, or you can do caret too. On your other calculators, you probably have an X to the Y button, or a Y to the X button, or you have the caret button probably. And then that is r squared. Often though, we'll talk about it as a percentage. So I'm going to multiply by 100, move decimal point over 2 places. So this tells me that 89% of the change in the the number of calories can be explained by an increase in the alcohol content. Okay, I hope you notice the language I use there. 89% of the change in the calorie content can be explained by change in the alcohol content. And then if we think about it as 100 minus that answer, about 11% can be explained by other things that we aren't measuring, lurking variables, et cetera, okay? So that's a pretty strong, that's a very high correlation. That's a really strong coefficient determination, percent variation. The other thing, though, the sneaky is you've got to look at the residual plot, because sometimes you'll have a high correlation coefficient, but you're looking at your data, it's really not that linear. This I'm pretty sure it is. So what you can do is, you see this, I guess I have high residuals. What it did is it calculated the errors from the line to the actual data. And if it's the points above the line, that's a positive residual. If it's below the line, it's a negative residual. And just in case you didn't catch this on another video, or you didn't read about it, let me show you how you get a residual. Let me get a pen going here. So what you do when you calculate a residual, and I'm going to ask you to do this on an exam, so let's make sure you know how to do it. So to calculate a residual, we do the actual value minus what the predicted value. Sometimes they call it fitted. So if this point, I have no idea. Of course, I can't read the number. But, well, maybe I could. Let's see here. Let's get fancy here. 0.4 and 70 is the actual. Looks like the line says, oh, here we go, right here, line of best fit. So 0.4, was that the residual? That must be the residual number. Well, actually, you can find it right here. Dan, what are you struggling for? So the percent of alcohol, the number of calories can be calculated by 0.914 times our 0.4% alcohol plus that y-intercept, 518. So since I've got that calculator opened up here, why don't we use that? So let's come over here so we can see something. So I'm going to do 21.914 times the 0.4 plus, not minus, plus 50.15, 50.518, is it? So that's my residual. Notice it's a positive residual. Boy, that seems high. 0.4 plus, okay, I guess that's what we're getting. So 59 calories, though. That's a predicted 59 calories. I guess that's not high, because if we look at our, let me get a pointer going here. The actual data is way up here at 70 calories, and our regression equation predicts 59, and we see that that's below it. Okay, so my actual is the 70, my predicted is the 59. So to get the residual, we're going to do 70 is the actual minus the predicted. I'm just going to be lazy and grab that since this calculator will let me do this. So that's my residual, 10.17. And you see in this residual table over there, that's the residual. So that's the error from the line. Notice it's positive. If I did the next one, it would be a negative residual, because the actual minus predicted is the actual is lower than what the predicted line is fitted. So that would be a negative residual. Okay. So what good is a residual for us? Well, if we zoom out here, let me do this. Let me zoom out here a little bit. And part of it is the scale. Let's see, I think I can tweak the line here. Okay, here's my 10.14 residual, or whatever it was. Here's the negative 37. And It's kind of hard to see in the scale because it won't let me change the scale. But what we're looking for with a residual plot, if you're not, we don't want to see any patterns. We want to see some randomness to this residual plot. As soon as we start seeing patterns, we know our linear model might not be the best model, that we should use, either do some work with the data, transform it, or use a different model, use a nonlinear model. I don't think we have time to have you do all that. I'm not going to make you do that in this short course. But that's where we would go with it. So I think with the correlation being so high, with that high R squared value that we calculated, and I'm not really seeing much of a pattern. Granted, I would like that to be a little more, a little more. How can I zoom in? Let me zoom in. Nope, I guess let reset it. Let's close window and show me my residual. See if it changes that. Yeah. So I'm seeing, oops. So I'm seeing, what am I seeing? Nope, I don't want to set the window. Here, show residuals. Let me try to move this around. So you see how I'm not seeing really a lot of a pattern. There's some pattern. I mean, there's a bunch of them down here that's negative. We can kind of see that in that cluster in the middle. And it's just the quirkiness of this data. I would say that this is probably random enough, looking at those R and R squared, that we're don't have to worry about. I think a linear model is a good fit for this data. Now, and the last thing I want to do before I leave the screen is, you can certainly write Y and X like they have here. I think when you're trying to draw connections and make a conclusion about what you're seeing, I think it's good to use actually words, write in the variables what you're measuring. So I've got calories equals 21.914 times the percent alcohol plus the y-intercept of what, 50.518. So that makes a lot more sense to me. And the other thing you want to add is put a little hat over the calories. Remember we did p hat and that was a sample proportion? Well, that was a predicted value. Well, these calories are going to be predicted value. So if you put a little hat over it, that kind of helps people who realize, oh, this is going to be a predicted value, and it's a little fancier. So okay, so that's how you use this applet to get your line of best fit. To have it draw the scatter plot, you can certainly screen capture that. And then do the residual plot, right? And that I got the residual plot by hide residuals, show residuals, right? So hopefully this will help you meet that learning target for me. Yeah, I think this video is long enough.